Hello students, welcome to the introductory video series on signals and system. In this video, we will discuss some examples of signals and the formal definition of signals. With the advent of the internet, the amount of audio, video and the image data has gone up. Processing this data for efficient storage for better human experience is a must. Also, it is required to process the data to infer pattern information or some trends from it. Even before the invention of the internet, the communication technology was evolving through wired and wireless radio channels. So these were happening in the First and Second World War, and they were able to communicate across the globe through the technology they have developed. It is a mature subject which has a lot of applications in different branches of engineering and our day-to-day life. And people used to store their data in magnetic tapes, optical discs and floppy disks. You can see the evolution of the storage devices when the concepts of signals and system evolved, and now we are storing all the data and information in clouds, and we are trying to process it using machine learning, artificial intelligence, neural network, etc. A very important characteristics of this kind of data is that it can be expressed as a function of an independent variable. So this concept is very important. So this data can be considered as a function of an independent variable. So this word is very important. All these signals or data or information can be expressed as a function of an independent variable. Most of the time in this subject, this independent variable is time. Now let us look into the formal definition of signals. The data or information about an underlying physical phenomenon expressed as a function of an independent variable is called signal. So let us try to analyze this definition again. So there should be a data or an information which should be based on some physical phenomenon. So what is meant by underlying physical phenomenon? There should be some physical phenomenon which generate this data or information. So this is expressed as a function of an independent variable. So that is what a signal is. The data or information about an underlying physical phenomenon expressed as a function of an independent variable, and most of the time it is time. So we use time as the independent variable, and then it is called a signal. So another definition is that a signal can be considered as a mathematical function. So we should keep in mind a signal can be considered as a mathematical function between an independent variable and a dependent variable. We can say that this is a mathematical function between an independent variable and a dependent variable. So there should be a dependent variable and an independent variable. So if we plot that function between this independent and dependent variable, then we will get a signal. So these three terms are important in the definition. There should be a mathematical function. That function should be between the independent variable and a dependent variable. Now let us see an example of a signal to understand more about this definition. So here I have shown a signal, and so here time is the independent variable. Here time is the independent variable and amplitude is the dependent variable. So what is meant by that? Here amplitude is varying with respect to time, right? So time will not wait for anybody, right? So time is keep on going like that in the x-axis, but based on the variation in the time, there are some changes in the amplitude. You can see how the amplitude is changing. The amplitude is changing with respect to time like this, right? So here amplitude is the independent variable and time is the dependent variable, and this amplitude is varying with respect to time. So that is the meaning of our definition, right? So here we have a mathematical function, a dependent variable, that is the amplitude of the signal, an independent variable, that is the time, and a physical phenomenon. So what is the physical phenomenon? Who generated this signal? Actually this signal is from a musical instrument, and that is a beat signal. Actually this signal is a beat signal generated from a musical instrument. What is the independent variable? Time is the independent variable which is marked in the x-axis, and what is the dependent variable? Amplitude of the signal is a dependent variable which is marked in the y-axis like this, right? And what is the mathematical function here? Yes, here we have a mathematical function. Actually this mathematical function behind the signal is given as y of t is equal to 4 sine t plus 5 cos t by 2. So this is the mathematical function which is generating a signal like this. So our definition is satisfied. There is a mathematical function that is nothing but 4 sin t plus 5 cos t by 2, and that should be based on some underlying physical phenomenon, that is a sound from the musical instrument, and we have an independent variable, that is time, and a dependent variable, amplitude of the signal. So that is the definition. So generally the word signal can be used as a noun or a verb, right? So when it is used as a noun, it means that it is a function of an independent variable, and when it is used as a verb, it means that it conveys some information. So whenever we ask to students what is the definition of a signal or what is meant by signal, most of the time students say that it is something which carries an information. Actually that is the verbal meaning of the signal, it carries some information, but the noun or the actual definition of signal is that it is a function of an independent variable, right? So there is a mathematical function, there is some underlying physical phenomena, there is a dependent variable, and there is an independent variable. So that is the formal definition of a signal, right? So we can have different kinds of signals as examples in our real life. So this is an example, eat your raisins outdoor on the porch step. So that is what somebody said in this signal, and this is the one dimensional signal, so speech signal, and we can see that there is time in the x-axis and there is amplitude in the y-axis, right? So this kind of signal which is having only one dependent variable and one independent variable, then such kind of signals are known as one-dimensional signals, 1D signal, right? So audio signals are examples of one-dimensional signal. Whenever we record something in our smartphone or whenever we record some sound in our computer, we are actually dealing with a one-dimensional signal. So audio is an example of a one-dimensional signal. Now coming to image, image can be considered as a two-dimensional signal. Why it is considered as a two-dimensional signal? Actually in the case of image, we have one dependent variable and two independent variables. Our independent variable is not time in the case of image, but it is space, right? So you have to move in the x direction and you have to move in the y direction in the case of an image. So in the case of a two-dimensional plane, we must have two coordinates to represent a position or a location. So image can be considered as a two-dimensional plane. When we take this particular location, we have to specify what is the y length and what is the x length. So there are two independent variables, right? This x length and y length are independent, and based on that something is varying. What is varying? Actually the brightness is varying here. Here the brightness is varying. So image can be considered as a two-dimensional signal in which the brightness of the pixels vary with respect to the space, or we can say that the x-axis and the y-axis, or with respect to two-dimensional plane, the brightness of the pixels are varying. So in that case we can consider image as a two-dimensional signal. Here also dependent variables and independent variables are there, but here we have two independent variables. That is why it is called a two-dimensional signal. Now coming to the video, video can be considered as a three-dimensional signal. Why it can be considered as three-dimensional signal? We know that videos are nothing but frames per second, right? Frames per second. So whenever we record some video, it will ask how many frames per second. That means how many images need to be recorded in 1 second. When these images are moving in front of our eyes, due to persistence of vision, we feel that it is a moving video. So that is the basic idea of video. Here three independent variables are there. So anyway we have frames. So frames can be also called as images. So frames can be also called as images. So because of that, image is already a 2D signal, and these frames or images are varying with respect to time. So this is the time axis. So you can see that the frames are varying with respect to time, right? Already frame is a two-dimensional signal and it is varying with respect to another independent variable, that is time. So here we have three independent variables. One is x-axis location and y-axis location and time. So we can say that in the case of a video, a pixel, so here the dependent variable, what is a dependent variable here? Here the dependent variable is pixel. Here the dependent variable is brightness of the, or intensity, okay, brightness of the pixel, brightness of the pixel, right? So this brightness of the pixel is varying with respect to time and with respect to position, right, or space. So video can be considered as a three-dimensional signals. Not only that, there are so many other examples for signal. For example, the voltage across the capacitor. So how a voltage and current varies when a capacitor is charging, right? The voltage is gradually increasing like this, right? So it is reaching to a peak voltage. So this also can be considered as a signal. And considering the current, how the current is varying in the capacitor, there is suddenly a huge current because of the electrons flowing to the capacitor, and gradually it is decreasing to 0. Once the capacitor is fully charged, there is no current, right? So this also can be considered as a signal. And some other examples are chemical concentration on the earth's surface, right? So when we move into different altitude, latitude and longitude, you can have different kind of chemical concentration. So if you plot that on a graph, that also can be considered as a signal. The latitude, longitude and altitude is independently varying, and the chemical concentration is depending on this variable, right? So here the dependent variable is chemical concentration, and the independent variables are latitude, longitude and altitude, right? So another example, when we consider biomedical engineering, it's all about signals, right? There is MRI, there is CT, there is ECG, there is EEG. There are so many signals in the case of biomedical engineering, right? So we can say that biomedical engineering is mostly about how to acquire the signals and how to process the signals and how to infer some information from the signals. And it is similar for electronics and communication engineering. It's all about signals, right? So electronics and communication engineers are mainly dealing with communication, right? How can we communicate from one place to another place through wired medium or wireless medium or optical medium, right? So everywhere we are transmitting some signals and we are receiving some signals and we are processing some signals, right? All these places contain applications of signals and systems, right? Not only that, there are so many other areas, right? This list is not complete. You can add more and more examples to this list. In fact, when you see this video in YouTube, actually that is also a signal. We can again come to the formal definition of signals and system. The signal can be defined like this: the data or information about an underlying physical phenomenon expressed as a function of an independent variable is called a signal. So there should be a physical phenomenon, there should be some data or information, it should be expressed as a function of a dependent variable. So most of the time in this subject we will be considering time as the independent variable. So that is the formal definition of signal. One more definition we have seen: a signal is a mathematical function between an independent variable and a dependent variable. So there should be an independent variable and there should be a dependent variable, right? Then we can call it as a signal. So don't forget these words: mathematical function, independent variable and dependent variable. Thank you for watching.